Hello, grade 9 students. I hope you are all good. And we all pray that what we are passing through finishes soon. This week we have a new mathematics lecture. We are continuing in the lesson we started last week, and the title of our lesson was Square Roots. The objectives of this lecture, number one, we will continue perform calculations with the square roots. Last week, we talked about addition and subtraction of square roots. This week, we'll talk about multiplication and division of square roots. Number two, expand and reduce an expression with the square roots. Number three, how we compare two square roots. Let's refresh our memory and solve an example of what was our lecture about last week. Let's simplify these radicals. Radical 11 squared, we have an important rule which says radical a squared equals a, such that a should be positive. So since 11 is positive, the squared cancels the radical and the answer is 11. Radical 13 squared, also the squared cancels the radical and the root is 13. Radical 2, all of it squared, the squared cancels the radical and the answer is 2. Radical negative 10 squared, this is a positive square root. Why? Since the minus here is also having an even exponent too, it becomes positive. So the squared cancels the radical, the answer is 10. We have an important rule which says radical 1 squared, the squared cancels the radical, the answer is 1. Radical 0 is always 0. Now radical minus a 3 squared, please pay attention for this. This is a negative radicand. Why? Since the squared has nothing to do with the minus, it's only for the 3. So my answer inside is negative 9. So since this is a negative radicand, we say it does not exist. Radical negative 7, since it is a negative radicand, minus 7 is negative, it also doesn't exist. Radical negative 25, since also it's a negative radicand, it does not exist. Now radical 49, 49 is positive, but it's not written squared. So we ask, can we write 49 as a perfect squared? Yes, it's written as radical 7 squared. The squared cancels the radical, so the answer is 7. Now let's perform addition and subtraction. We have an important rule in addition and subtraction of radicals. The rule says we can only add or subtract similar or like radicands. What do we mean by this? Radicals that have the same radicands inside. So before adding or subtracting, we should check if the radicands are similar. Here we have radical 10 and here we have radical 10. We add or subtract as the rule says the coefficient and we keep the radicand as it is. Who's the coefficient here? It's a 3. The coefficient here is 8. So 3 plus 8 is 11 and we keep radical 10 as it is. So the answer is 11 radical 10. Radical 13 plus 6 radical 13, they are similar. Here the coefficient, we have no coefficient. So it is 1. 1 plus 6 is 7. So it's 7 radical 13. 9 radical 2 minus 5 radical 2, since they are similar radicals. So 9 minus 5 is 4 and we keep radical 2 as it is. Minus 5 radical 7 minus 8 radical 7, they are similar. Minus 5 minus 8, the coefficients is minus 13 and we keep radical 7 as it is. 7 radical 3 minus 10 radical 5. These are different radicals. We cannot add or subtract different radicals, so the answer stays as it is. 7 radical 3 minus 10 radical 5. 4 plus 3 radical 11. 4 is a number. 3 radical 11 has a radical. We cannot add a number with a radical, so since they are different, they are staying as they are. Now 3 radical 50 plus 7 radical 8 minus 15 radical 2. We are adding and subtracting, but the radicands, as you can see, 58 and 2 are different. But 50, is it a prime number or we can decompose it into prime factors? No, it's not a prime number. It can be decomposed. 8 can be decomposed using prime factorization. 2 is a prime number, so it stays as it is. It cannot be decomposed. So we have to write 2 decompositions of prime factors for 50 and 8. These are the prime factors of 50, 2 times 5 squared, and these are the prime factors of 8, 2 squared times 2. These prime factors that we got here, we replace them under the radical. So now we replace. Instead of radical 50, we write 3 radical. Instead of 50, we write 2 times 5 squared plus 7 radical. Instead of 8, we write 2 squared times 2, and we keep minus 15 radical 2 as it is. Now, in the first radical, 5 squared comes out as 5, but since we have 3 outside, so we multiply 3 times 5 radical 2. Here, 2 squared comes out as 2, so we multiply plus 7 times 2 radical 2 minus 15 radical 2. Now we multiply the numbers outside. 3 times 5 is 15 radical 2 plus 14 radical 2 minus 15 radical 2. Now, as you can see, all the radicands are the same. Radical 2, radical 2, radical 2. So we add or subtract the coefficients. 15 plus 14 is 29 minus 15. So it is, the answer will be 14 radical 2. Please apply this slide very well. It summarizes our lecture of last week. Now we'll continue in performing calculations with square roots. The calculation we'll talk about now is multiplication of square roots. In multiplication of square roots, we have 3 rules. This is the first rule, this is the second rule, this is the third rule. Please memorize and understand these 3 rules very well, because whenever you see a similar to the rule, you will know which rule to apply. A times radical B. What's A? A is a number and radical B is a radical. So if I am multiplying a number with a radical, the number stays outside as a coefficient and the radical stays as it is. So A times radical B equal A radical B. As an example, 3 times radical 7. It is 3 radical 7. The number stays as it is, as a coefficient, and the radical stays as it is. 11 times radical 5 is 11 radical 5. Radical 11 times 7, here the radical coming before the number, it's the same. So it is 7 radical 11. The second rule, radical A times radical B. We are multiplying 2 radicals having different radicands. So we keep the radical and we multiply the radicands. AB means A times B. Radical 7 times radical 3. We are multiplying different radicals. So it's radical and 3 times 7, the answer is 21. We directly write radical 21. Radical 5 times radical 2. So different radicals. So we say it's radical 5 times 2, which is radical 10. 2 radical 3 times 4 radical 2. Here I have a coefficient in the first radical and I have a coefficient in the second radical. Whenever you have coefficients, you multiply coefficient times coefficient, then radical times radical. So 2 times 4 is 8. Radical 3 times radical 2 is radical 6. The third rule, radical A times radical A equal, here I'm multiplying radical A by itself 2 times. So I write it radical A, all of it squared. The squared cancels the radical, so my answer is 8. What's the difference between number 2 and rule number 3? Rule number 2, we are multiplying different radicands. Rule number 3, we are multiplying same radicands. So as examples, radical 3 times radical 3, it gives me radical 3, all of it squared. The squared cancels the radical. It comes out as a 3. 5 radical 7 times 2 radical 7. As I said, whenever we have coefficients first, we multiply the coefficients. 5 times 2 is 10. Radical 7 times radical 7 is radical 7, all of it squared. Here the 10 is outside, so it stays as 10. The squared cancels the radical. The 7 gets out as 7. But since outside I have 10, so we multiply 10 times 7 is 70. Another example, 5 radical 2 times 3 radical 2. First, 5 times 3 is 15. Radical 2 times radical 2 is radical 2 squared. The squared cancels the radical. It comes out as 2. So 15 times 2 is equal to 30. These rules are very important to memorize and to apply the examples. We'll continue with calculations, and now we'll talk about division. Division, we can write it as a fraction. Suppose you have radical A over radical B. Each radical, so in the numerator we have a radical and in the denominator we have a radical. If they are written in this way, we can write all the fraction inside the same radical. So radical A over B. Or if we have a fraction inside the same radical, we can split the numerator and the denominator, each one is inside a radical. So radical A over radical B. Radical 7 over radical 12. How do we write it? We write them inside the same radical. So we write radical 7 over 12. 7 is a prime number. It stays as it is. 12, it can be decomposed into prime factors. So I decompose it to 2 squared times 3. Here, 2 squared comes outside as 2. So I will have radical 7 over 2 radical 3. We can keep it like this, or we can write radical 7 and radical 3 in the same radical. Here, since the coefficient is 1, so I write it 1 over 2 radical 7, all of it over 3 in the same radical. Radical 15 over radical 6. So we write the numerator. 15 cannot be decomposed into prime factors and 6 cannot be decomposed into prime factors. So we write radical 15 over 6. Now the fraction inside the same radical, whenever they are written splitted, we cannot simplify. We can simplify the fraction if it is written inside one radical. So 15 and 6 both can be divided by 3. 15 divided by 3 is 5 and 6 divided by 3 is 2. So the answer is radical 5 over 2. Now radical 30 or radical 36 over radical 16. 36 can be written as a perfect squared and 16 can be written as a perfect squared. So 36 is written as radical 6 squared. Radical 16 can be written as radical 4 squared. Now radical 6 squared, it comes out as 6 and radical 4 squared comes out as 4. Our fraction should be simplified or irreducible. 6 and 4 we can reduce by 2. 6 divided by 2 is a 3 and 4 divided by 2 is 2. Now radical 25 over 3. Now this fraction, it cannot be reduced, but we can split the numerator and the denominator, each one inside a radical. So we can write it radical 25 over radical 3. Now radical 25 can be written as a perfect squared. It comes out as 5. So the answer is 5 over radical 3. These are the rules of division of square roots. Also, as I always say, apply these exercises very well. Now, if you have radical A times B, we can split in the case of multiplication, each one inside a radical, and we can split the radical in case of division. But the splitting cannot be done in the case of addition and subtraction. So if we have radical A plus B, we cannot write it radical A plus radical B. We cannot split in case, if you can see inside, in case of addition and subtraction, we cannot split. If you have radical 4 plus 9, you add 4 plus 9, it gives you radical 13. But we cannot write radical 4 plus radical 9. This cannot be written in the case of addition. Please, this is very important. Also, if you have radical 9 minus 4, we calculate 9 minus 4, it gives me radical 11. Now, radical 4 squared plus 3 squared, also in the case of multiplication, we cannot split, so we calculate 4 squared is 16 and 3 squared is 9. So radical 16 plus 9 is radical 25 and the answer is 5. Since 25 can be written as a perfect squared, it's written radical 5 squared, so the answer is 5. Here, they are given splitted. I didn't split them. They are given in this way. So 9 can be written as a perfect squared and 4 can be written as a perfect squared. Here 3 squared comes out as a 3 and 2 squared comes out as 2. So 3 minus 2 is 1. Now, how can we expand and reduce an expression? To expand an expression, we use the rules that we studied last year, the rules of expanding. What does expand mean? We should get rid of the parentheses. So I might have m into a plus or minus b. The rule says m times a is ma and plus or minus m times b is mb. We worked on these rules too much last year. We might have two parentheses multiplied together. m plus or minus n into a plus or minus b. We multiply the first by the first by the second by the first, then the second by the second. This is the rule. Or we might use remarkable identities. If you have a plus b all of it squared, this is the first remarkable identity. It's a squared plus 2ab plus b squared. The second remarkable identity, a minus b all of it squared. It's a squared minus 2ab plus b squared. The third remarkable identity, two parentheses multiplied together, but we have the same numbers inside. A minus b into a plus b is a squared minus b squared. We will choose one of these 5 rules in order to develop or to expand these exercises. First, I have 2 radical 3 into 5 plus radical 3. Here we have a parenthesis multiplied by something, so we apply the first rule. 2 radical 3 times 5, 2 times 5 is 10 radical 3. 2 radical 3 times plus radical 3. Positive times positive is positive. Here the coefficient is 1. 2 times 1 is 2. Radical 3 times radical 3 is radical 3 squared. Now the squared cancels the radical. It comes out as 2. So 10 radical 3 plus 2 times 3 equal 10 radical 3 plus 6. Of course, this cannot be added because we have a radical with a number. Here I have 2 parentheses multiplied together. We might apply this rule or the last rule in remarkable identities. If I look inside, do I have the same numbers inside? No, so we cannot apply the third remarkable identity. We apply this rule. The first by the first by the second by the first, and the second by the second. So we get this answer. Now, radical 3 squared, the squared cancels the radical, it gets out as 3. Minus 3 radical 3 plus 2 radical 3, since they have the same radicands, we can subtract them. Minus 3 plus 2 is minus radical 3. So we get 9 minus radical 3 minus 2. Of course, 9 minus 2 is 7 minus radical 3. This is the answer. I have parentheses squared, and inside I have a plus, so I apply the first remarkable identity. A squared, which means radical 5, all of it squared. The squared cancels the radical, so it gives me 5 plus 2ab. I multiply radical 5 by 2, it's 2 radical 5 by 2, since we are multiplying by 2 here, so it's 4 radical 5 plus b squared, which is 2 squared, the answer is 4. We can reduce 5 plus 4, which is 9 plus 4 radical 5. We cannot add or subtract anymore. Here we apply the second remarkable identity, a squared, which is 1 squared, the answer is 1, minus 2ab. 1 times 2 radical 3 is 2 radical 3 times 2, which is 4 radical 3, plus b squared, which is 2 radical 3, all of it squared. Now I calculate this. Radical 3, all of it squared, the squared cancels the radical. 2 squared is 4, so 4 times 3, which is 12. So 1 plus 12 is 13 minus 4 radical 3. Here I'm applying remarkable identities, calculation, okay? The last example, we apply remarkable identity 3, since we have the same numbers inside. One is positive, the other is negative. So the answer will be a squared minus b squared. A is a 3, we make it squared, so it's 9 minus radical 2, all of it squared. Radical 2, the squared cancels the radical, so it gets out as 2. So 9 minus 2, the answer is 7. Believe me, if you solve these exercises on draft, they ease your work when you solve the worksheet, because I will be giving you a similar example on the worksheet to solve it. This is very important. The last objective for today, how we compare square roots. Comparing means I should know which one is greater if they are equal, or which one is smaller. I might be comparing a number with a square root. If I'm comparing a number with a square root, we cannot compare. To be able to compare, we square both. So we get the answer of a squared, we get the answer of radical b squared, which is b. Now I compare a squared with b to know if a is greater than, less than, or equal to radical b. I might be comparing a radical with a radical. Also, I square both. I get radical A squared and I get radical B squared. So these are the rules of comparing square roots. We square both. We get the answer square of both. To get rid of the radical, we make it square. As examples, I'm comparing radical 7 with radical 10. I square both. Radical 7 is radical 7 squared. Radical 10 is radical 10 squared. The squared cancels the radical. It comes out as 7. The squared cancels the radical. It comes out as 10. 7 is less than 10. Then radical 7 is less than radical 10. As easy as this. 5 compared to radical 17. I'm comparing a number with a radical. Also, I square both. 5 squared is 25. Radical 17 squared. The squared cancels the radical. The answer is 17. 25 is greater than 17. So 5 is greater than radical 17. Similar here, I square both. I get 3 radical 2 squared, 2 radical 3 squared. Please pay attention to this writing. Here, the square is given for both, for 3 and for radical 2. 3 squared is 9, radical 2 squared is 2. So 9 times 2 and 4 times 3, this is 18 and 12. If I compare 18 and 12, it's greater than, so the first is greater than the second. Please pay attention when you are comparing negative radicals. You also square both with the sign. Negative squared becomes positive and 6 squared becomes 6. Since this is a negative base, okay? 6 is greater than 3. So minus radical 6 is less than minus radical 3. Since when we compare negative, we shift or we make it in the opposite. If they are greater than, it becomes smaller than. So these also exercises are very important to solve before solving the worksheet I'm sending this week. This was our lecture for this week. Please watch the video well, and if you have any question, don't hesitate to contact me. I'm not hearing anything from you, grade 9 students. I hope you are understanding everything. Bye.